Question 4 is the proof of tan A minus B. Your knowledge here is that tan is equal to sine over cos. From here it's pretty simple. So we've got the sine of A minus B. To get tan A minus B is sine over the cos of A minus B. Then we go to our tables and we see what this is. Compound angles. So the sine of A minus B is sine A sine B. No, it's not. It's sine A cos B minus cos A sine B. Be careful with these. It's so easy to go wrong. And then double check. Sine A minus B, sine A cos B minus cos A sine B. You can tie yourself in knots with these. Divided by cos A minus B, cos A cos B plus sine A sine B. And the key to this question really is just identifying this one. How do I get a 1 in this position here? I'd have to divide everything by cos A cos B. So if I do that, you can do it off to the side if you want. Sine A cos B divided by cos A cos B. I'll show you what will happen here. The cos B's will cancel and we get sine A over cos A. So you could put that back in. So you can put back in equals sine A over cos A, because you're dividing by cos A cos B. And then we'll have minus off to the side your cos A sine B divided by cos A cos B is going to give you, with the cos A is cancelling, sine B over cos B. And then divided by, we can bring the 1 in straight away for this guy. We're dividing that by the same thing. So that's going to be a 1. And they're going to have plus, and we can put it in here, sine A sine B divided by cos A cos B. And you can see that these two are going to give me tan A tan B. So we can tidy this up now. Sine A over cos A is equal to tan A minus sine B over cos B is tan B divided by the 1 plus this guy, the product tan A tan B. Tan, not tan, tan. That's it proven. QED. Move on to the next part. Part B. It's kind of connected to part 1, but I think SIRS might be the easiest way to do this, or the quickest. Tan 15 in this form. So if you type tan 15 on your calculator, that'd be obviously the first thing to do. Let your calculator do it for you. That's equal to 2 minus root 3. And then we go back to the form they're looking at for it in. And we can see that we want a root A on top and a root A in the bottom, so the roots have to be the same. And we have a root 3 already kind of in our answer. So I want a root something plus 1 on the bottom. So why don't I put a root 3 plus 1 on the bottom? This is clever maths. So that would mean if I do that to the bottom, I'd have to do the same to the top. And the top is 2 minus root 3. So multiplying out the top, I get root 3 times 2, which is 2 root 3. I get root 3 by minus root 3, which is minus 3. 1 by 2 plus 2. And 1 by minus root 3 is minus root 3 all over. What we wanted on the bottom was a root something plus 1, root 3 plus 1. So I now have 2 root 3 minus root 3 is just 1 root 3. And I have minus 3 plus 2 is minus 1 over root 3 plus 1. Nice tidy little question. Clever examiner writing these questions. Part B of this question, triangle ABC is shown. A, B, C, identify the diagram. AC is equal to BC. AC is equal to BC. And the angle ACB is 45. So then the two angles at the bottom are equal. 180 minus 45 divided by 2 is 135 over 2, which is 67.5 degrees. We're asked to find AC So what can we do here? I could use sine rule maybe. Might be the easiest way to do it. Or I could drop a perpendicular bisector down here. This will be then 5 times 2 minus root 2. And I have 67.5 in here. So I've got my right angle triangle with my angle 67.5. I'll call it A. 5 times 2 minus root 2, just to confuse you. And we're looking for x, so we're doing the adjacent and hypotenuse. So the cos of 67.5 is equal to 5 by the square root of 2 minus root 2 over h. So hx is equal to 5 by the square root of 2 minus root 2 over the cos of 67.5, and x is equal to 10 in this case exactly. We're given units here, just given 10, so x is equal to 10 units for the end of question 4.